All right, so we are going to move on with the second example. And as you see here, there is a mass being pushed to the right by some applied force. The mass is 60 kilograms. This dotted line is the normal, so that angle is 40 degrees, which means our angle above the horizontal would be 50 degrees. It's always 90 minus the vertical angle. So it says, examine the diagram to the left. Which force F is required to keep the 60 kilogram mass in static equilibrium? So what we start with, first of all, is that F net has to be, as you guessed it, 0 newtons. So we always begin with a free body diagram. So we have our FG going down. We have this tension here. So we'll just call that T. So T is going up on an angle. And we got F to the right. Notice that F is in one dimension, so it's only an X component. But this is two-dimensional, which if I draw on a little X-axis, if that vertical angle is 40, this angle must be 50. We would have TY going up, and of course, TY going to the left, TX going to the left, and notice that it's going to the west, which is negative. Okay, so we set up our F net statements for X and Y. We'll go straight now to, we know F net has to be 0. So F net X 0 must equal, let's write the F net statement, F, which is our unknown, plus negative TX, because it's going to the left, which leads us to 0 equals F minus TX, and TX equals F, which is very important because if we find TX, okay, then we solve for unknown force. So now we go to our Y, and we know F net Y is 0. So what forces are acting in the Y component? Well, negative FG, of course, because weight is always negative, and we add TY. So we know mg, so we can move that over, okay, by subtracting. So Fg equals Ty. Fg is equal to 60 times 9.8, and that equals Ty. Now, Ty, of course, if we look at our triangle for tension as we have up here, okay, Ty is the opposite side. So there's Y and X, and that's 50 degrees. So Ty would equal T times sine 50, and Tx would equal T times cos 50. Okay, which that's going to come back over here. So that equals T sine 50. So now we can isolate T. T equals 60 times 9.8 divided by sine 50. So look at this here, make sure we're in degree mode. So we're going to go 60 times 9.8, and we're going to divide that by sine 50, and we get 767.579. 767.579 newtons. So back down here, I'll just switch it around. F equals Tx, which is T times cos 50. Okay, so now we're just back solving like that. So F would equal, and again, you should keep all your decimals, so I'll just write 767.579 times cos 50. So we'll go 767.579 times cos 50. And we get 493.39 newtons. So again, we look at sig figs, and it appears that we have the 60.0, which is 3 sig figs. So we need 3 sig figs in our answer. So the F must equal 493 newtons. And that is how we solve static equilibrium problem number 2.